Hi, my name is Benjamin, and today we will be talking about the TIBCO Intelligent Equipment Accelerator. High-value capital equipment in industries such as utilities, oil and gas, manufacturing, and mining are in general highly instrumented with sensors used to provide insights on how the equipment is performing. The strategies for equipment maintenance are shifting from a reactive to a real-time and predictive model, where being only reactive to failures leads to more downtime and associated costs. In contradiction, a predictive model reduces the production losses and improves the overall equipment efficiency, or OEE, by increasing the useful life of the equipment. Applying this to the oil and gas industry, we can monitor equipment such as an electrical submersible pump for performance and health signs. We can analyze the data coming back from the pump and optimize its lifespan by decreasing the maintenance interval and reducing the amount of physical intervention required by the field engineers. This equipment is generally not deployed in isolation, but is instead part of a network which works together to deliver a business outcome. A defining characteristic of such a network is that non-optimal performance or even total failure of a single piece of equipment has a negative effect on the overall performance of the whole network. For example, if you look at an electrical submersible pump, you will find many sensors reading microparameters, for example power output and motor vibration, internal parameters, for example motor temperature, current, and intake temperature, and environmental parameters, for example external temperature. The data captured by these sensor networks provide insight into the historical and current performance of the equipment. It is with this type of data and volume in mind that TIBCO has created an intelligent equipment accelerator to provide a standardized, reusable, configuration-driven framework for integrating sensor data sources, such as the one mentioned previously, with business analytics tools. Business analytic tools focus on the democratization of data analytics, making it easy for the more business-focused user to analyze data, find trends, and generate statistical models. In our oil and gas use case, the tools allow domain experts to analyze historical sensor data to highlight previous failures of a pump, identify patterns and anomalies with the aid of the statistical services, and generate predictive models to expose the correlation between failures and a particular sensor value threshold. Some leading indicators for pump failure are a large increase in motor temperature causing an electrical short and an unusual changes in pressure forcing the pump to shut down. Those models can then either generate a condition score for a piece of equipment assembly or indicate a possible imminent failure. The thresholds and other model parameters are used to configure the appropriate modules in the accelerator and turn that knowledge into detection logic to be applied to the streaming data. Example of this detection logic could be when the current reading of any sensors trends toward 680 amps in any 15 minutes window, then generate an alert and create a case. Alerts can be as simple as an email or tied into case management, asset management, business process management, or other ways your business needs to handle the alert. The same data that has been used for the analytics purpose is also used for the streaming analytics engine. This engine consumes time series data which consists of high volumes of simple contextless data, for example an ID, value, and a timestamp, and populates a live data mart with contextual data. The accelerator is able to score the data coming from a single sensor and assemble all readings from related sensors together into an array of scored values. It can also aggregate the scored data over one or more time windows and apply statistics to the aggregated data. Scoring, aggregation, and statistics are implemented via the mechanism of extension points, which makes it possible for a developer to add new implementation or replace the out-of-the-box ones. The accelerator provides a simple interface and core functionality for dealing with sensor data analytics so that the developer only needs to integrate their source of sensor data with the accelerator. It also allows the developer to define specific condition logic to identify a situation of interest through the scoring mechanism and simplify the customization of the visualization and alerts in a way that reflects business needs. This intelligent equipment accelerator offers a robust solution to monitor and predict equipment failure based on historic data. By using the same monitoring model but applying it to the current stream of data, we can use the new information and feed it back into the system to refine the predictive model. With this continuous improvement of the models, we are able to prevent loss of production and therefore increase the revenue of the production.